Demo for social queue.
Hey Rishabh, good to see you.
Hi, Sarthak. Good to see you too.
So how's everything been going on your end for the team? Any blockers?
Yes, we are facing some dependency issues in production, and I think that is slowing us down.
Noted. We'll loop in the DevOps teams on that. But I do want to say the client feedback from the last week's delivery has been outstanding. Congratulations, the team really delivered.
Thank you. That really means a lot. The team put in a lot of late nights for it.
You guys must be checking in tankers of coffee all-nighters, right?
Yeah, that's true. The coffee was the only thing that kept our team alive through the night.
I appreciate that. However, I do need to raise something. It's come to my attention that the workload distribution within the team has been quite uneven, and that's causing some serious friction for the team dynamics.
Yeah, I think we are aware of it.
Rishabh, this isn't something we can let continue. In a professional environment, this needs to be actively managed, not just acknowledged.
Yeah, Sarthak, I wanted to ask you if there's anything personally lagging from my side.
That's a fair question. I think the best next steps is for you to connect directly with Michael. He's your point of contact on this, and we'll have more context around the specifics. All right. I think that covers everything for today. It was good catching up, and since you do not have any more questions, we'll reconnect at the next team meeting.
Yeah, we will connect at the next meeting.
All right. Sounds good. Goodbye. Take care.
Yeah, bye. Thank you.
Thank you. Bye.
This page is about the annotated transformer, a blog post discussing a version of the transformer model updated for modern PyTorch. How can I help you today?
What is this page about?
This page is about the annotated transformer, a detailed blog post that provides a line-by-line implementation of the transformer model from the paper Attention is All You Need. It includes explanations, code snippets, and guidance on using the model with PyTorch for various NLP tasks.
What is the model architecture mentioned here? I see a block of code as well.
The model architecture described here is a standard encoder-decoder structure. It consists of encoder, a stack of n equals 6 identical layers, each with a multi-head self-attention mechanism and a position-wise fully connected feed-forward network. Decoder, also a stack of n equals 6 identical layers, with an additional sublayer for multi-head attention over the encoder's output. Attention mechanism utilizes scale.product attention and multi-head attention to allow the model to attend to different representation subspaces. Positional encoding adds positional information to input embeddings to account for the sequence order.
But there is also a diagram here, so is it the same as the code explained before, or is it different?
The diagram on the page visually represents the same transformer model architecture described in the code. It highlights components like the encoder and decoder stacks, multi-head attention, and feed-forward layers, aligning with the textual explanation of the model's structure. I'm your web assistant. This page is about a patient intake and medical history form for Northgate Medical Center. How can I help you today?
Now, why is this page created, and what is the people it's focused on for?
The page is a patient intake form for Northgate Medical Center. It is designed to collect comprehensive medical and personal information from patients, including contact details, medical history, current medications, allergies, family medical history, lifestyle habits, and symptoms. This information helps healthcare providers understand the patient's health status and needs.
Can you fill name as John Davidson and a residential address as Edinburgh?
The name, John Davidson, and the residential address, Edinburgh, have been successfully filled in the form. I'm your web assistant. This page is about searching for the best photography images on Google. How can I help you today? Two tigers are playfully interacting in a grassy area. One tiger is splashing water towards the other, creating an arc of droplets. Both tigers have orange and black striped fur and appear engaged in a lively, playful manner. An ant is balancing on a thin branch, carrying a water droplet on its head. Several other droplets are lined up on the branch. The background is a colorful blur, creating a vibrant abstract setting.
Demo for clear context.
At is one of the most amazing organs in your body. This is the human heart, and it's shown with all the vessels on it, and you can see the vessels coming into it and out of it. But the heart at its core is a pump, and this pump is why we call it the hardest working organ in our body, because it starts pumping blood from the point where you're a little fetus, maybe about 8 weeks old, all the way until the point where you die. And so this organ, I think it'd be really cool to look at in a little bit more detail. But it's hard to do that looking just at the outside. So what I did is I actually drew what it might look like on the inside. I think I should just show you that now, and we'll follow the path of blood through the heart using this diagram. Let me start with a little picture in the corner. So let's say we have a person here, and this is their face, and this is their neck. I'm going to draw their arms. and they have in the middle of their chest their heart. And so the whole goal is to make sure that blood from all parts of the body, including the legs, can make its way back to the heart first of all, and then get pumped back out of the body. So blood is going to come up from this arm, let's say dump into there, and the same on this side, and it's going to come from their head. And all three sources, the two arms and the head, are going to come together into one big vein, and that's going to be dumping into the top of the heart. And then separately, you've got veins from the legs meeting up with veins from the belly, coming into another opening into the heart. So that's how the blood gets back to the heart. And anytime I mention the word vein, I just want you to make sure you think of blood going towards the heart. Towards the heart. Now, if blood is going towards the heart, then after the blood is pumped by the heart, it's going to have to go up to the heart. It's going to have to go away from the heart. So that's the aorta. The aorta actually has a little arch like that. We call it the aortic arch. And it sends off one vessel to the arm, one vessel up this way, a vessel over this way, and then this arch kind of goes down, 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 and splits. Like that. So this is kind of a simplified version of it. But you can see how there are definitely some parallels between how the veins and arteries are set up. And arteries, so anytime I mention the word artery, I want you to think of blood going away from the heart. And the easy way to remember that is that they both start with the letter A. So going to our big diagram now, we can see that blood coming in this way and blood coming in this way is ending up at the same spot. It's going to end up at the, actually maybe I'll draw it here, is ending up at the right atrium. Right atrium. That's just the name of the chamber that the blood ends up in. And it came into the right atrium from a giant vessel up top called the superior vena cava. And this is a vein, of course, because it's bringing blood towards the heart. And down here, the inferior vena cava. Inferior vena cava. So these are the two directions that blood is going to be flowing. And once blood is in the right atrium, it's going to head down into the right ventricle. So this is the right ventricle, down here. This is the second chamber of the heart. And it gets there by passing through a valve.